All right, looking at number 3, it says polonium has a half-life of 138 days. Write the decay function for the amount of polonium that remains in the sample after t days, and estimate the time for polonium to get 0.1 of its initial amount. All right, so I know that this is going to be an exponential decay function. So I know that when I set this up, it's going to be y is equal to a b to the t, where a is my initial value and b, is what I'm multiplying by each time. So in this case, because going back to my equation, I'm going to look at how could I figure out my initial value. Polonium has a half-life of 138 days, and then that's all they gave me. What the heck? All right, so I know I'm going to have to use the 138 days, and half-life means I'm halving, taking half and then a half and then a half, so multiply by 1/2, multiply by 1/2, multiply by 1/2 of what I originally had. This question doesn't give me an initial amount. When the question doesn't give you an initial amount, what I do, and they're talking about like a percentage, is I assume the initial amount is 1. Polonium, let's say we have like 1 of those because we're talking about percentage here. So my initial amount is going to be 1. What I'm multiplying by each time, if I'm having it, half-life, that means times 1/2, times 1/2, times 1/2. So here I have 1/2, or you can say 0.5 here, same thing. And then let's talk about my exponent. So this is the tricky part. Half-life of 138 days. That means every 138 days, I half the amount of polonium that I have. Now, if I just have, and it wants t in days. So if I just put t here, what that says is I'm having every single day. But I want to have every 138 days. So that means my exponent needs to be t over 138. Because let's say, let's say 138 plus another 138. That's 276 days that go by. That means in that 276 days, I would have halved my amount 2 times. So what I'd have here in t, I need to basically, if I had 276, I'd plug that in for the days, so t would be 276. 276 divided by 138 would give me 2, which makes sense since I'm having 2 times. So if, just like if we were to have every other day, that means we're having every 2 days, so I would say t divided by 2. But in this case, since I'm having every 138 days, then it's t divided by 138. All right, so my equation is going to be y is equal to, I'm going to get rid of this 1 because it's just like, it's going to be invisible now. T to the over 138 power. Okay, so that was the first part of the question. Now let's go on to the second part. Estimate the time for polonium to get 0.1 of its initial amount. Well, our initial amount we just said was 1. So 0.1 is the same thing as 10%. So 10% of 1 is 0.1. So that means my y value is going to be 0.1 is equal to 1/2 to the t over 138. Now I can solve for time. How many days will it take for my sample to get to 0.1, so 10% of what it started with? So what do I have to do? Logs to the rescue. If I'm going to solve for what t is and it's in the exponent, I do the inverse operation of exponentials and I take the log of both sides. So I'm going to have log of 0.1 is equal to log of 1/2 to the t over 138. So the whole point of logs is we drop the exponent down, and we're going to have log of 0.1 is equal to t over 138 times log of 1/2. All right, remember what it is I'm solving for. I'm solving for this t. Now it's no longer an exponent, so we just made our lives a lot easier. But everything else around this t, I want to get to the other side. So I'm dividing by 138 here. So the inverse operation of division is multiplication. So to get rid of this 138 and bring it to the other side, I'm going to multiply by 138. So if I multiply by 138 to this side, that crosses these out. I got to do it to this side then. So now I have 138 log 0.1 is equal to t times log 1/2. So the only thing I have left now to get t alone is this t is being multiplied by the log 1/2. So the inverse operation of multiplication is division. So to get rid of this, I'm going to divide. 1/2 is the same thing as 0.5. So if you want to write that, you can. So I'm going to have t, remember t is in days. You always have to remember what your units are. 138 log 0.1 over log 1/2. I'm just going to change this 1/2 to 0.5 just so I stay consistent, so I don't have decimals and then fractions. I just want to stay consistent there. But if you left the 1/2 there, that's okay. So if I'm plugging this into the calculator to estimate how many days, I'm going to have, let's get my online calculator going. All right, we had 138 times log of 0.1, and let's see what that equals, divided by log of 0.5, which equals 458.426. Now, because this is in days, I'm just going to round. So I'm going to say 458 days. So this is about 400, wait, was it 458? Yeah, 458 days to get 10%, 0.1 of what I originally started with. So 400 days, that's if you have a calculator, or if it's a multiple choice on the test, it might write it like this: 138 log 0.5 times 0.1. And I'm going to put that in parentheses there just so you can make sure you know which is the base. Oh gosh, I'm making that worse. All right. Phew. Cool.